So it's really critical that when something does happen in the field, which it does every time, that you have those plan Bs. And a lot of the Carport groups that I've worked with in the past, they do a good job of that, of saying, hey, okay, here's plan B, here's plan C, here's all your different foundation designs. Where I've found in the industry where that real gap is that, okay, now these have to be reviewed and added to the draw package and re-stamped, and then the materials then will be modified and have to get to the site so the installation can stay in sequence.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.
The clean energy industry is moving fast. The deals are getting bigger, the technology is evolving, and the stakes have never been higher. Welcome to the Clean Power Hour, the podcast for solar, storage, and microgrid professionals who want to stay ahead of it all. Each week, your host, Tim Montague, industry advisor and president of Clean Power Consulting Group, brings you unfiltered conversations with the leaders actually building the energy transition. Now, here's your host, Tim Montague.
Welcome to Carport Solar Done Right, a Clean Power Hour live webinar. I'm Tim Montague, your host. I've spent the last 10 years in the commercial solar industry, and if there's one thing I've learned, it's this. Some projects forgive mistakes, carports do not. One wrong assumption about soil conditions, one structural detail overlooked, one steel price swing between bid and build, one unexpected conflict underground, and any one of those things can wipe out your margin. All of them together can sink a company. And yet carports are becoming one of the fastest growing and most misunderstood segments of commercial solar. Schools, hospitals, manufacturing facilities, corporate campuses, municipalities, everyone wants covered parking that also produces clean electricity. So if you've ever priced a carport project or you're thinking about bidding one, you're going to get a lot out of this next hour. The opportunity is enormous, but only if you understand how these projects actually work. Today's goal isn't to sell you a racking system, it's to give you a framework from first bid to commissioning, so you can avoid the expensive mistakes, protect your margins, and build structures that are still standing and producing 50 years from now. That's why we brought together today's panel. Between them, they've engineered, manufactured, reviewed, and installed hundreds of megawatts of solar structures. It's my pleasure to introduce our panel. Kyle Sinclair is CEO and co-founder of Sinclair Designs and Engineering, SDE. Kyle and his team design and manufacture ground mount and carport racking here in America with a reputation for solving hard structural problems instead of avoiding them. Kyle is a U.S. Navy veteran who served as an intelligence chief with Navy Special Warfare, and he brings the same precision to building solar infrastructure. Kyle, welcome.
Thank you, Tim. Warm welcome to everyone joining the webinar today.
James Strizky is with GenMounts, Renewable Energy Holdings in Flemington, New Jersey. James lives in the field. He's responsible for actually getting these projects built, which means he understands exactly where engineering drawings meet the reality of ground conditions, construction schedules, and change orders. James, great to have you.
Tim, thank you very much for having me.
And finally, Matt Boyce is principal engineer at Engineered Solutions. Matt has 18 years of general contracting experience across commercial, industrial, municipal, and heavy highway work, plus 15 years of structural engineering and design. He holds a PE license in 27 states, and he reviews projects from an independent standpoint, helping owners, developers, and EPCs build assets that will perform for decades, not just pass inspection. Matt, welcome.
Thank you. Thank you for the opportunity.
Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. Wonderful. Well, let's jump in, gentlemen. Kyle, big picture first. Why do experienced EPCs who can build a flawless rooftop system still get surprised when they move into carports?
So to answer your question directly, EPCs that are new to installing carports are often surprised by that higher level of heavy construction that is required with these types of projects.
Matt, you're an independent reviewer here, so I want you next. By the time a project reaches your desk, what are the most common engineering mistakes you're already finding baked in?
I wouldn't necessarily say that they're mistakes, but they could be potential pitfalls that we could come up with. Because by the time I see a project, we know like the really big aspects that affect the design are: where is it? What are the geographical concerns, be it wind load, snow load, the types of soils that we run into. So once I see it, we know all of that. So it's just a matter of making sure that the trusted and proven design that we have works in a particular location that we're deciding to install. The biggest potential pitfall is everybody looks out across a parking lot and says, oh, well, this will be perfect for solar. And that's not true. So, we could do our due diligence and get geotechnical studies done, drill some test holes and find out what all is under that beautiful parking lot that you have to find out where we could potentially have problems. And we try. And it's not that we try, we do design for the information that we receive from that. But the biggest problem that we could run into is unforeseen conditions. We're only going to drill so many holes, and depending on the size of the project, we could hit an old foundation. We could hit a sinkhole or some sort of void. We could get bad soils, high plastic clays. So we just have to be on the lookout for what we would need to do to address that. So going back to the pitfall part of it is the developer has got to have contingency in for that, because that's the biggest unforeseen condition.
Indeed. So James, how much of what Kyle and Matt just described to you do you actually see once the crew is on site? And where do projects start to experience challenges or potentially unravel?
Projects really start to unravel right from the initial steps. Basically, like any project and any house and anything you do kind of in life, you have to start with a firm foundation and then build up from there. Well, in carports, the foundation can be the hardest, is usually 99.9% of the time the hardest part of the project. As Matt kind of described earlier, if we come across soils that are not consistent with what we initially thought they were going to be, or we hit obstructions in the ground, or we find that there's utilities that weren't necessarily found before. It can derail a project really quickly. And it's not only that it derails the project quickly from a standpoint of not being able to build it, depending on what you uncover in the ground, it can actually even absolutely kill projects. I've had that happen to me in the past where we excavated on a project and we found out that there were 4-foot voids underneath the parking lot that were previous heating ducts made of brick. So it's once we can get through the foundations and working with those, the project goes a lot more seamless. But the foundations, I'd say every time is where customers can and ourselves can be derailed from a financial perspective. And I guess one other real big point is that when you come up across these foundation issues, you always have a lot of people and a lot of subcontractors or a lot of vendors in line, whether it be concrete or just manpower. And when you have people sitting stagnant at prevailing wages, it can exponentially blow up the budget.
So if I can summarize, carports aren't harder because they're solar. They're harder because of inherent uncertainty in the ground, the structure, and potentially the supply chain, although I think that's probably the least of our concerns. So let's move into part 2, how a good project actually happens. Let's walk a successful project. Pretend I'm an EPC who just won my first carport job. What happens next? Kyle, where do we start?
I would say that the EPCs that win the most have actually spent a little money for preliminary engineering, so they can provide an accurate bid based on that validated information. So our repeat buyers have a lot of success with that strategy, and we can easily recoup some of that initial cost when certain projects move forward. So, if we have kind of a 30% close rate, on these bigger jobs. So a lot of that initial engineering cost can be recouped at a later date. In our work
on that too, just to add to that. And I couldn't agree with Kyle more. The beginning due diligence process is paramount to any successful project. And I have been fortunate and unfortunate to work with people on both ends of that spectrum. The people that are willing to put up the due diligence, whether to find more soil conditions, to do test pits, to do soil borings, to talk to previous building, to talk to the maintenance owners or the maintenance directors that normally have the most experience with the building and the people that have been there the longest. The information that you can get that's free and is just takes time to get is usually worth more than anything that you get out of a geotech report, specifically when it comes to those foundations. The second part of that, which Kyle also mentioned, the due diligence of getting plans. Sometimes we have surveys that were existent but are not brought to us. I actually had a project just 2 weeks ago that a customer, I asked again, and I was like, do you have any records of a previous survey or anything? They then went back to the customer, and this is actually upon already drilling foundations. And it was over an existing parking structure, like an actual parking garage that was demolished. He was then able to locate the site plans and the construction plans of the previous parking garage, which then at that point, we had to design on the fly and redesign our conceptual drawings to now customize design where the foundations were going to go to miss the existing structures. So these are all steps that, unfortunately became brought to our attention later, but if they are done initially, you can save, tens, 20s, 30s, 50,000s of dollars by just doing a very, very detailed due diligence process. And I'm sorry, I didn't mean to interrupt, but
no, please. There's really, to add on to James's points there, there's kind of 4 main processes in our workflow that we work on really closely with both Matt and James. First is that geotechnical study. And preliminary engineering for the foundations to be able to provide some upfront cost analysis. And then Matt does a really good job at the finite element analysis of the structure against the site-specific building code requirements. Following that, we go into a full internal design review as a team because, Matt may specify different grades and gauges and yield strengths or different profiles of the components to make sure that we're engineering these structures for long lifespans. So it's very important that our team catches those details and that we're procuring the materials and that those batch of materials are specified to the exact project. And then the last step is, manufacturing product deployment, which is mainly from the Sinclair design side. But once that project is official, GenMounts is going to ask those EPCs to issue a deposit to launch the formal engineering review. Everyone's busy this year. The commercial space is booming. Licensed PE's hourly rates are kind of like lawyers' fees. So when I call Matt or James, I'm like, don't talk too slowly or drag out the conversations, because we know how expensive, the time can be. And once those deposits are issued, Matt will review the geotech soil report, which is critical for determining the foundation sizes, provide early insight into those design requirements. What size hole needs to be drilled? Is there a high risk of underground obstructions? Is there limestone, granite, shale, or caliche layers? Also, is there a risk of high water tables? Is that area in a flood zone? Those sites can have a dramatic impact on the overall cost for those foundations. And then next, when we do the full structural design review, Matt reviews the site-specific load requirements for the FEA, and it lets us know early, whether our standard components need upgrading. And this is really where things get interesting, because we try to prioritize those design decisions with the manufacturing and procurement hat. So it's easy for the professional engineers to run the calcs and say, hey, you need this size I-beam. But it can be challenging on the procurement side, especially with long roll schedule lead times with the mills. So we can often find a quicker and more cost-effective option, such as welding additional gussets or adding more bracing or using higher yield strength materials. Oftentimes that leads to quicker lead times, and it's more cost-effective for the end users. And then kind of those last steps is James and his team, plans for all civil underground obstacles, such as communication, electrical, gas, water, sewer, any prior steel metal obstructions from previous site developments. That's very common in a lot of the projects that we do. They also work really closely with the electrical contractors, so we can design where the conduit runs need to be placed, which side in our columns, to add holes for those conduit runs. And then at that point, once that's complete, it's tailored to the installation schedule. And once foundation cages are deployed, we really focus on manufacturing, hot dip galvanizing, and scheduling delivery to meet their install requirements.
Yeah, it may be obvious to some of our listeners, but we're dealing with urban settings for the most part here, right? And so you just don't know what was there prior to that parking lot. And we are largely talking about parking lots. Not always, but the vast majority. And so it just looks like a parking lot, right? But you have no idea what's under the ground 5 feet down. And so that is a huge challenge, which we're going to continue to discuss probably throughout this webinar. Matt or James, though, do you want to contribute anything else to this discussion right now? This is really great. You guys are making my job very easy.
My part's kind of easy in all of this. I am the most reactive person, so I hear about projects where Kyle or James will send me one and say, hey, we just want some preliminary ideas on this one. This is some of the information that we were able to put together. A lot of times, again, on the soils, James and his team sometimes will track down previously done geotech analysis from an adjacent property or whatever, which we can use, just to get an idea of the concept of what we're going to see underground. But another cautionary thing about underground is that, again, you look out across the parking lot and, everybody sees like this like nice black top with some light poles or whatever. But, and then you have the old timer on the property that's been around there for 40 years said, well, we've never built anything here and there's never been a utility across here and everything should be fine, right? But we ran into a project here recently up in Minnesota where that parking lot was constructed on 6 or 8 feet of fill dirt, which is terrible to try to build on. It's usually just thrown in there, especially for a parking lot. It's never compacted properly and it's useless to build on. So, if you think that, oh, well, nothing's ever been built here, we should be fine, that's not necessarily the case. So again, that the reason why these conditions are unforeseen is because we have no idea until we go out there and put a shovel in the ground.
And James and Kyle, I'm curious, how many different foundation types do you commonly see with carports? Because I'm a relative novice in this particular niche space, but how many types of foundations are there?
I'd say there are typically 2 types of foundations that we usually depend on. The preferred method, which is just due to the fact of it being as expeditious and for what you're doing, you get very good results from lateral resistance and moment capacity, is drilled shafts. Drilled shafts are basically you take an auger or a core barrel, you drill down, you remove the spoils, you get down to undisturbed earth. The foundation depth is all determined based on math calculations. And then after that, you either can do one of a couple things. If it's a clay cohesive type soil, you're able to potentially put the foundation, the rebar cages, basically suspend them in the air with temporary formwork and then pour the concrete up against earth, which is the best method from our experience, and due to the fact that you're putting concrete, it's basically in direct contact with earth and there's no intermedium and you're getting skin friction and you're filling all voids. It's the best of both worlds. The challenges come when you get into non-cohesive soils that are then filling in the hole, which can create all sorts of issues. In the past, we've had to go anywhere from temporary casings where you have to put in CMP, which is corrugated metal pipe that keeps the hole where you then have to insert the foundation cage into, keeps it free of debris from other dirt falling in. But when you do that, you have to make sure that there's no voids around the casing that you're leaving in. So you either have to compact it or have flowable fill placed around that casing. The next type of foundation would be a spread type footing. That's usually used when the soil is becoming so non-cohesive that it's all collapsing and it's becoming a ginormous hole, or if there's obstructions in the ground that you're not able to go below a certain depth. And that happens, that can happen. The last type of foundation I had, which was like a hybrid between the two, was we were working in soils that had very low bearing capacity. It was almost like muck and mush in the Northeast near Newark, New Jersey, where it was actually a combination of helical piles that were screwed 30 foot into the ground and then were had a pure cap and were cast into the concrete foundation. And that was to prevent differential settlement over a period of time. So those are typically the 3 that I see that I've been experienced with the most. I always recommend to the customer that I try to get anything that I can that is available at minimal cost and or free. 811 dig calls, that's public utilities. Any public utility, when you call into 811 dig or Dig Julie or any of the ones in your area, they will come out and they have to mark out public utilities. That is a very good stepping point of saying, okay, well, we know we want to put out a carport. Let's let them at least come out and they will mark out sewer, gas, water, telecom. You then kind of get an idea of what you're looking for. They do not mark out private utilities, but at least it gets you a starting point. I think this is probably the one comment that I would make that I see the least completed in construction with all of the people I work with. Again, going back to the due diligence process, once you have a drawing that you think is going to be the drawing and the foundations that you need to build and the structure you need to build, it is best to go out maybe a week prior with a skeleton type crew to actually go and do an informal layout. And I'm not saying it needs to be survey grade, but it needs to go and say, okay, hey, I know I'm going to be drilling a foundation in this area. What obstructions do I actually have? And you may laugh because I'm talking about, or you may laugh at me for what that comment is because it seems like common sense. But even when we put these on plans, when we actually go out in the field, they're I'd say almost every time there's a curb line or there's a stepped parking lot or there's storm sewers or there's water lines or things that we somehow were not relayed in the field or not relayed into the office when we were doing the initial design. And just doing that saves when you deploy having so many people sitting around looking at you asking what to do. And that's probably like the one most valuable point I can put out for any kind of construction project is start slow and then go from there.
Yeah, and we've had quite a bit of, I would say, a diverse portfolio of designing foundation cages for all sorts of applications. Some not even in the solar industry. So we've taken a lot of those lessons learned from designing foundations for antenna structures, satellite tracking systems, and we've been able to apply a lot of that to the solar industry with these larger carport formats. So it's really critical that when something does happen in the field, which it does every time, that you have those plan Bs. And a lot of the carport groups that I've worked with in the past, they do a good job at that, of saying, hey, okay, here's plan B, here's plan C, here's all your different foundation designs. Where I've found in the industry where that real gap is that, okay, now these have to be reviewed and added to the draw package and re-stamped. And then the materials then will be modified and have to get to the site so the installation can stay in sequence. And that's a lot of the gripes and complaints that we hear out in the field, from installers working with other groups. So what we really tried to do is focus and streamline that process where, Matt mentioned he's very reactive to those situations. He's ready to take those calls. He's ready to review and provide an option. And then on the Sinclair side, we're ready to make those adjustments on the manufacturing and deploy updated cages out quickly to keep the installers on schedule.
The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more. All right, let's move on to part 3, where the money is won and lost. Because 2 things on our materials about this show were pricing and steel, and I want to make good on both. So Kyle, start with soil. You've told me to budget for the worst case on geotech. For an EPC pricing a bid, what does that actually mean in dollars, and how do you price for foundation variability without either getting burned on pricing yourself or pricing yourself out of the job? It really is a double bind.
Yeah, it is a balancing act, but I think it's really important to provide that visibility into what those worst case costs could be per foundation. That geotechnical report provides a lot of good information, but you never know really what you're going to hit underground. And so for example, when drilling through Michigan clay with no obstructions, we can anticipate paying $800 per drilled hole. But if we hit hard shale at 4 to 6 feet deep, which is very common in southern Michigan, that price can jump up to $2,500 per hole. That adds up quickly on a 0.5 megawatt project site where the drillers have to switch to rock drilling with carbide cutters and hook up water lines. This can easily add 60K to the equation, and that's a 12 cent per watt flex. So it's just important that the EPCs have visibility into those worst case scenarios, so they don't put themselves in a position. Do we think, hey, we're going to this site and we think every hole is probably going to require those updated costs? Very unlikely. But you should have some buffer in a percentage based on that geotech report that gives you a realistic target to chase. So having those secondary foundation options is critical. And in some circumstances too, when you hit high water tables, or experience soils that are too soft, we have to switch to those spread footers designs, and those cages are more expensive. And the installers may need to rent additional equipment for excavating and that surface area. This leads to more dirt being hauled off the site and has a compounding effect with labor time. So, just providing that visibility is so important. You mentioned, not pricing yourself out of the job in your question. And to be honest, sometimes, pricing ourselves out of the job can be intentional on the manufacturer and installer side. That some of these EPCs want manufacturers to sign contracts with delivery deadlines, but we can't even start engineering because they haven't selected a solar panel, or they want to negotiate flexible payment terms over a 9-month project timeline. And my company name is Sinclair Designs and Engineering, not Sinclair Community Credit Union. So we avoid assisting the developers with financing these projects because that's not what we're built to do as manufacturers. So we really just come in, vetting these partners. We're not going in to sell these. I've never been a big fan of selling carports. I'm a true believer that there shouldn't be commissions tied to these types of projects because there's already so many variables. And moreover, you have a lot of sales reps in the industry that don't have that technical expertise or don't really add a lot of value to that project development. So I really encourage, the folks that are listening in, to do your homework. Who are you having the discussions with about your carport project development? Are you speaking, with engineers, and are they focused on risk mitigation? Or, are you relying on someone with a high school diploma who's throwing 20% of markup onto the project just because they answered the phone that day? So we hear a lot of those gripes and complaints from out in the field from other solutions. And that's something that we're really focused on solving.
We're getting some good questions in the Q&A. I would encourage the attendees to put your questions in the Q&A, and we'll get to as many of those as we can. When, you think about EPC, and this is for all of you panelists, engineering, procurement, and construction, how does pricing a job break down? It seems to me that there's a lot of uncertainty on the front end and less so on procurement and construction. But Matt and James, talk about this EPC and where are the prices for a project more firm than others?
So I'll chime in on that, Tim. A lot of times when we're selling to an EPC, I guess it depends on which entity we're ultimately dealing with. And let me kind of clear that up, I guess, a little bit. When we work with customers that usually can either sell to an end user, to somebody else after that. And when it's that case, we don't necessarily know what their budget is or what their project scope and what they're selling to their customer. We have a foundation or we have a carport scope of, they consider us just, racking. It's enveloped into racking. Obviously you would have engineering design, racking, you have the electrical side, you have the interconnect side, you have the equipment for the solar panels. So we're filled into that little envelope. In other cases, if we're dealing with full EPCs that are owning the projects, that's when it's a little bit easier where, we have the line of communication with who we're working with of saying, hey, based on all of the information that you've given us, here's what we think could happen. And this is, again, like, I can't stress enough that it really starts with the foundations. The foundations of any project I've ever worked on, whether it's carports, ground mounts, they're, the make or break of how the rest of your project's going to go. So what we try to relay to our customer, who's the next person in line of whether they're selling it or not, is that here's what we think we could come up against, and how do you want to handle it? Now, by that I mean we have some customers that go, we can't, we only can take a full all-in price. So they'll tell us, and they'll say, you need to just tell me, you need to give me a price that you can get this done, because I cannot go back to my customer and ask for more money or do anything else. So in that case, it becomes really difficult where myself, Matt, Kyle, we're all looking at the project and saying, okay, here's what I think it looks like. Here's what I think I could be up against. Here's what I'm predicting the problems to be. And then I need to have enough of a contingency to be able to do all of this work, not lose money, and still tell the customer that, hey, I gave you this price and this is the all-in price and I can do it. And that's the way it's going to be. And I've had jobs, a lot of our jobs recently, that's what they are, where we went out, they said, just give me the price, but don't come back to me again. Like, you need to give me a price so you get it done. We went out, we thought we were going to be able to drill foundations. We start drilling, the holes start collapsing. We then have to get temporary casings installed. It pushes you back a couple of days, but we didn't go back to the customer. There wasn't any of being able to do that. And contra to that, we have customers that say, hey, we are value engineering this where, if there are problems, we understand. We don't want you to go and kill us on this, but we want to do whatever needs to be done that's right. But, we'll share in the headache of a rough foundation. And normally when we come across that, from our side, we're very transparent. We say, hey, no one wanted to have this, but if it's rock drilling, or we need to bring an auger, or we need to bring out hydrovac, which we've used, it's XYZ price, 3,000 for this, a couple thousand for this. A lot of times we just show the costs and say, hey, it's this plus our guys, and we're trying to get through this. So being able to be on the same team, not only with Kyle and Matt, but with whoever we're working with, is really paramount. And it's managing expectations and managing the expectations of what things we can be up against and how it's going to be financially covered. Because unfortunately, I've learned this from the hard way, that as much as you don't like having to have conversations about things costing more money up front, it's really, really, really bad to try to have them after you're already into it. And, we've learned from that. And unfortunately, sometimes, we've taken just losses on saying, hey, we're going to get this done and we didn't see this coming, but we want to get it done. And we want to have happy customers and happy partnerships and long lasting partnerships than, make a couple dollars on one job.
If our industry could avoid one problem, what would the three of you identify as one problem to avoid? Matt, Kyle, James?
The second, part of this that's probably not something that's talked about much, but is the reason that myself and our company does what we do, is that me as an engineer myself, I take pride in saying, if I don't like giving answers on the fly, that if I don't know the answer on the fly, I'm not going to give it to you. Even if that's something that you're not going to like, I am going to say, hey, I have many people since I've been doing this for, I guess 20, 23, 24 years, that I will talk to the people that probably know more about the specific facet of whatever we're talking about. But the point I'm getting at is that in some cases, maybe don't take on more than you think you should. By that, I mean, we've sold projects to people that believe they can build these things. And we had customers initially when we were first, starting getting into carports, probably about 10 years ago or 8 years ago, that were like, yeah, we can build it. We know how to build it. We feel very, very confident. Said, okay, so, you sell the system, they go and build it, you engineer it. Well, when things are not built correctly, they don't necessarily rear their ugly head right away. What ends up happening is a year, 2 years, maybe even a little bit later. Usually it's probably within a year. That's when you start seeing the problems. And some of the problems that we've seen when holes aren't drilled correctly and casings are placed and they don't have fill properly placed behind them, that's when you get consolidation over time later, or even some undermining. So I've seen undermined parking lots where all of the fill under the parking lots kind of collapsed. I've seen some issues where things were added after the fact with electrical conduits that shouldn't have been done. So it's the experience that you're going to get out of a carport structure and the longevity and not having the issues is doing it right with someone that knows how to do it, and working with people that know what they're doing versus trying to just go do it the first time.
Well said. Matt, Kyle?
I think I could just piggyback a little bit on what James said. So my background before I traded in my boots for a calculator was I have poured 100,000 yards of concrete. We've done some pretty heavy construction, and if someone is new to this, then a lot of new people would have a tendency to be a little bit lower on every single step than they should be. And for instance, like if someone tells you that you need 8 people out there on the site, then they send out 6. And if someone says that you need a large material handler, then somebody will send out a backhoe. Or if you need like a carpenter or a group of carpenters, a crew or millwrights to set your anchor bolt cages so that they don't move when you're pouring, or you have the right crane or material handler to set the columns and make sure everything's plumb. And it's just when we think we could do it with this, we think we could do it with this. And this isn't like when the economy is booming, everybody thinks that they can be a building inspector. This is heavy construction, and it has to be done right, because everything piles on afterwards. So you can't do this halfway. It has to be done right. And from where I grew up, a lot of people might have an issue with this, but from where I grew up, that meant you get a union foundation contractor or a union ironworkers or union electricians, because in the area that I grew up in St. Louis, Missouri, unions were highly reputable and they did amazing, impeccable work. Okay. That may not be the case everywhere. Okay. And it may not be the case today, but back then, but that's the level of quality that needs to happen with this, because when you get to the end of it, at the end of all the heavy construction, you have to put solar panels to create a roof for this, and they have to fit. And you can't be jockeying them around, and everything has to fit. So everything has to go off of, so you can't go out thinking, oh, well, I can do this. And the other thing is that if you're a purchaser of construction, either a developer, EPC, just a property owner or whatever, if you're a purchaser of this construction, you have to be able to say, I don't know. You have to know when you don't know something, and then rely on the experts, the people in this room, to be able to walk you through it, because you trusted them enough to call them ahead of time. You got to trust them with the answers. They're not going to lead you astray. We're all going to make our money. Nobody's going to hit a home run off of your job. So, we're all here because at the end of the day, Kyle wants to take a picture of your installation, add it to his wall saying, we did that. And everybody wants to walk away from a job that they can be proud of. So the purchaser of construction, just because you built a house or flipped a house or whatever, it does not necessarily mean that you're ready to do this. So doesn't mean you can't. It means rely on the people that do know.
Sure.
I did want to answer your question just because it's real fast on, if I could eliminate a mistake from the industry. My answer was ground mount trackers. So I wish we could just get rid of them as a joke. Obviously, I'm biased towards fixed tilt. But, one thing that I think there is a big gap in the industry is having long-term maintenance clearly outlined, no matter what your system is, if it's a fixed tilt ground mount, fixed tilt carports, or tracking system. So make sure that those long-term maintenance is clearly outlined and that you have a plan on that for the future.
All right. Well, I'm going to start with a question from Peter. What about existing structures? Here in the Southwest, Tucson area, there are already so many carports existing for shade. It seems like they would be ideal for installations. Can you repurpose an existing carport for a solar carport?
Potentially you can. Depending on what the original use of that structure was. If it was just a shade structure, then traditionally those are either designed to the lowest possible standard in the building code or none at all. So you do have to do a due diligence, because anytime you walk up to an existing structure, there's always the thought, especially in my mind, did they even get a permit for this? Because there are some structures that you see that the answer is obviously yes. And some is no, they absolutely did not. So the other thing is that we're changing the use of that structure now. And most importantly, out of anybody in this room, I have to put my stamp on it. So it better be right, because I will not put my stamp on it if it's not. So we won't compromise on any of that, because if I seal something, that means I say that it's safe and it's safe forever. And I will not take liability for a structure that someone built that I don't necessarily trust. Now, that being said, if it does look good and we could do a little bit of testing, like find out what the depth of the foundation is and whatever else, we would definitely be open to doing that. So we wouldn't rule that out just by rote, because, we didn't design the structure. So chances are, though, if a structure is not specifically designed for this, it's probably not going to be good enough for this.
Do you guys see a big difference in different regions of the country, like the Northeast or the Southeast or the Midwest or the Southwest, in terms of the amount or the importance of geotech?
Again, that one's me. I won't do a project without a geotech.
I'll chime in on that too, Matt. Like, the geotech is going to give you the initial, kind of background of what you're looking at and what you're seeing. Now, I would say, out of many, many times, you could say it's clay soil that is supposed to be cohesive. And many times I've gone there and it is not. So as far as the geotech goes from the engineering standpoint, yes, 100% can be needed. From the construction standpoint of what are you going to run into when you build it, it's very, very difficult. Difficult in kind of knowing what you're going to be up against. A lot of times what I rely on is, once I know where the project is, and if we're all over the country, I will do all my due diligence. Again, I really stress the 3 items. I'll go on web soil GIS software. I will type in geotech for the area and just look through any geotechs I can find. I'll go on Google Maps and take a look at the street view and see if I see outcroppings, or see if I see any areas where there's construction and they're going, even just driving around, going through Google Maps, you can see if there's a site that's being built, and you can kind of see what the soil looks like when they dig it. Then after that, as the project kind of evolves or gets closer to actually starting, I will call numerous drilling companies that are in the area. They are obviously usually worth a wealth of knowledge. Like that, they're the easiest ones to go to. But with that said, when I call them, I usually make sure I'm calling them when I have a real project. Like, no one wants to just have their time wasted. So they're the ones that'll tell you, hey, I've drilled in this area. Here's what we're looking to go up against. And that's where you really can make sure you know what you think you're going to have to be prepared with. Like temporary casings, you're going to hit rock, whatever the cases are. And they're really the best people to kind of reach out to and know what they think they're going to expect. And they could even give you some preliminary numbers saying, hey, we've drilled holes in that area. You could probably get this far down in about this many time, expect this many holes per day.
Yeah, and Tim, 90% of the time it's not a new geotech, right? The infrastructure is already there. The building likely has a geotech report from when the structure was built within the last, 20 or 30 year window. So we're able to utilize that specific data for these jobs. The other thing is a lot of the jobs that we partner on are municipal projects that have some type of state grant funding tied to it, and they require geotech analysis on all of those jobs.
I'm left with a big question mark about contingency when you're pricing a project. And I wonder if you guys could break down the big buckets for how to budget properly for a project. Obviously, dialogue with companies like Sinclair and GenMounts is critical on the front end, and I think that has come through loud and clear. But can you speak to how to think about approaching pricing and just speak in rules of thumb? One of my rules of thumb is you can expect to spend 2x on a price per watt or 3x sometimes on a price per watt on a carport. And that's the number one deal killer. Everyone wants a carport in their parking lot, but when it comes to affordability, if you can do rooftop solar, that's going to be much more affordable. But how do you guys see this?
I can talk a little bit about the steel side. I'll let I think James will have better visibility into total project costing, but we've been pretty good on the steel side with trying to lock in a fixed rate for those customers, with material deposit money, knowing that, hey, this could be a year before they get a permit approval and building approval and they're already dialed in. So we normally have, if your project is less than 2 megawatts, we likely have the raw materials already in stock or in the pipeline. So we're very comfortable with, hey, let's focus on fixing your cost on the structural components, and then they can pivot to working with Matt and James on adding buffer and analyzing the costs based on the foundation requirements.
Hey guys, are you a residential solar installer doing light commercial but wanting to scale into large C&I solar? I'm Tim Montague. I've developed over 150 megawatts of commercial solar, and I've solved the problem that you're having. You don't know what tools and technologies you need in order to successfully close 100 kW to megawatt scale projects. I've developed a commercial solar accelerator to help installers exactly like you. Just go to cleanpowerhour.com, click on strategy, and book a call today. It's totally free with no obligation. Thanks for being a listener. I really appreciate you listening to the pod. And I'm Tim Montague. Let's grow solar and storage. Go to Clean Power Hour and click strategy today. Thanks so much. Well, unfortunately, we're out of time. And this was a really great conversation. I want to thank the panelists, Kyle, James, and Matt, for making time for us today. Tell a friend about the show. Check all of our content out at cleanpowerhour.com. And I would love it if our panelists would just let our audience know how they can best reach you.
Yeah, we're getting busy this summer, but shoot me an email. That's the best way to contact me. It's kyle@sinclair-designs.net.
Although I would like my answer to be, you could reach me by emailing Kyle at Kyle Sinclair, but you can reach me at Matt Boyce, MATTBOYCE 39 @gmail.com. I will caution you that this is a team, and I don't have a tremendous amount of capacity outside of this team for any new work because of all of my client commitments. So you could still email me. If you got a really great job, I might be interested in looking at it.
And James Trisky.
For me, you can reach me at James, JAMES, at GenMounts, GenMounts.com. You can also look at www.genmounts.com or www.rehsolar.com. One, the REH solar has been mostly what we've been doing with the actual construction side of things. The other side is racking. If you guys need solar racking help, we can help you out with that.
And with that, I want to say thank you for joining us, everyone. It's been great to have you for Carport Solar Done Right. I'm Tim Montague. Let's grow solar and storage. Take care, everyone. The Clean Power Hour is brought to you by CPS America, maker of North America's #1 three-phase string inverter, with over 10 gigawatts shipped in the U.S. The CPS product lineup includes string inverters ranging from 25 kW to 350 kW. Their flagship inverter, the CPS 350 kW, is designed to work with solar plants ranging from 2 megawatts to 2 gigawatts. CPS is the world's most bankable inverter brand and is America's #1 choice for solar plants, now offering solutions for commercial, utility, ESS, and balance of system requirements. Go to chintpowersystems.com or call 855-584-7168 to find out more.